I'm going to show you how to generate IV with the help of the platform, for example, the Java platform in this case. In the past, we have seen how to generate IVs from our application. Sometimes that's not necessarily convenient. There is an interesting option. We can let the Java programming language to automatically pick a random IV for us during encryption. And then we can ask the Java platform, give me the IV that I need to decrypt. So that's a very interesting way to handle IVs. Okay, we can avoid some mistakes made by programmers by accidentally using the same IV and that kind of basic mistakes that we talked about earlier. So here is this code that I am going to show you a little bit detailed. I call it platform generated IV, and we have two plain texts. They both are the same. I just kept it same for a particular demo reason, right? And then we use the AES key size 256. Okay, so what I'm doing currently is simple. I have created an AES key object, the key generator object, and then generated the AES key, which is of course the same key both sender and receiver will use, Alice and Bob in our case. Symmetric key, traditional symmetric key cryptography. And I'm using in this demo AES in CTR mode, the counter mode. You could use CBC mode if you want. That's not the main point of the demo. What I wanted to show you though is that, as you can see here, during encrypt process, we initialize the cipher, right? We don't specify anywhere an IV here. In the past, we had an extra argument. The third argument used to be an IV. But now we are not doing it. We let the platform generate an IV for us. At this point, IV is implicitly generated by the Java platform in this case. And of course, during decryption, we would need an IV. So we can ask the Java platform before asking the decryptor to decrypt the data, please give me the encoded IV that you have. So Alice Cipher is basically the Cipher object that she created. She will get the IV, and then she will send the IV ciphertext to the receiver. Of course, the receiver would have to have the IV, otherwise he or she wouldn't be able to decrypt. In this case, Bob would need the IV, and that's the reason Alice is preparing the IV for Bob. And then extra one thing we need to note here is that during decryption, Bob has to initialize the algorithm parameters and use exactly the same encoded parameters Alice got. Remember, encoded parameters have the IV built inside. Okay, so that's basically the reason why Bob is also using the same encoded params here and here. All right, then it's the traditional steps. Initialize the cipher for decrypt mode, and here you are passing the AES params. AES params is already initialized to the IV, right? And now we can go ahead and decrypt the data. That's all. So let's compile and run, and I want to show you a few important things here. Java C platform generated IV, Java. Okay, so don't worry about the 18. I'll come back to it in a moment. Here is an IV for the first message, and here is the ciphertext of the first message. And this is the plain text of the first message after decryption, and it's shown in hex. Hex 41 means AA, so we have all these A's here, right? That's what exactly we put in as part of the plain text secret. Of course, you wouldn't put secret in the code, but this is just for a demo to show you how you can get the implicit IV created for you. Okay, and then if it comes to the second message, which is also AAs, but if you look at the ciphertext, it's different. This ciphertext is different from this ciphertext. That's exactly what we want. We don't want to leak the fact that our plain texts are the same, and we achieved it because we have a new IV generated by the platform. And one thing I wanted to highlight though is that number 18 means the length of the encoded parameter. Usually, if you remember, AES as a block cipher has 128-bit block length. Therefore, the IV in many modes are also 128-bit. Okay, but 128-bit means only 16 bytes. So where are the remaining 2 bytes coming from? If you look at the first 2 bytes carefully, it's the same here. This is just because of the DER encoding format. DER is the format Java uses to encode the parameters, so we don't have to worry about the first 2 bytes, meaning 0410, 0410. That's the reason they are same. If you run it again, let me run it again. You will still see 0410, 0410. Okay. All right. So just a little bit of information, because I was surprised when I created an array of 16 bytes and out of bound exception happened. But then I digged into the details of that encoding algorithm, and then I realized it's DER format. Anyway, so the main message is that we can let the Java platform to generate the IV for us. However, during the decryption process, the IV has to be available. At the time of encryption, we should ask the platform, what is the IV you generated? And then you send that IV to the decryptor. Otherwise, the decryptor won't be able to decrypt your ciphertext. Okay, that's basically what I have done here. Excuse me. All right, thank you very much.